Uh, Hello everyone. Am I audible? Yes. Okay. So sharing
Hi.
my screen.
Hi, Vinay. Yes, we can hear you.
Sorry.
Yeah, can hear you. Yes.
Okay. 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 Thank you. Okay. So yeah. So in the last class, I have told that we have completed our feature engineering technique, like the complete. Okay. And from today's class, what we will do, we will start with the all the machine learning algorithm one by one, and we will use this feature engineering technique before applying some kind of machine learning algorithm. And after that, we will finally try to predict a kind of output from our data set, right? So this is the first step. Mainly, your machine learning techniques are moreover divided into the two parts, right? The feature engineering is one of the important part. After that, we have the model selection, right? What kind of algorithm you are going to select, and along with that, there is a kind of hyperparameter tuning associated with that model selection, right? Hyperparameter tuning. Okay. So once you are able to do this feature engineering technique, or you are able to do the pre-processing of your raw data and convert it into some clean data. Okay. So what you can do, you can basically apply some different algorithm and do the hyperparameter tuning, and at last you will be able to just to finally predict the result. Okay. So this is the overall scenario of the machine learning techniques. Okay, how the machine learning techniques happen, right? All kind of algorithm run in the same way. Okay. So what we will do, we'll start today's lecture with a very simple algorithm of the machine learning, right? That is your linear regression. Okay. And whenever we will need that, okay, we need to do this some kind of feature engineering, some kind of finding the outliers in the data, maybe not in the initial phase just like the linear regression is concerned, maybe in the logistic regression or some other kind of machine learning technique if we need. So we will perform the kind of feature engineering technique over some data, okay, the data set that we have, and after that we will try to implement that particular algorithm, right? And this is how the complete process flow. Okay. So starting with the linear regression. Okay. So yeah, starting with the linear regression. So basically linear regression is divided into three parts, right? And regression mean prediction, right? It's mean the prediction. Okay. That I have already told you in the beginning of the classes, right? So linear regression is basically divided into three parts. Okay. The first part is known as simple linear regression. Okay, the very simple one, simple linear regression. After that, we have multi-level linear regression. Okay, next we have polynomial linear regression. Okay, so these are the basically three types of linear regression we have in the machine learning. Okay, so these are some starting algorithm that we will do. Okay, we will try to finish these two algorithm in this class. Maybe we will try, if it is able to, we will finish. Okay, we will not go in that much of hurry, right? So starting with the simple linear regression. So let's understand what is simple linear regression. Okay, and what is multilinear regression and what is polynomial linear regression. Suppose whenever you have two column in your data set, right? Whenever you have two column only two column, right? The one is your input column and the other is your output column, right? Maybe suppose your input column is CGPA and your output column is package, right? Only two columns are there. So at this scenario, whenever you have only these two columns, okay, one is your input and the second one is your output column in your data set. At those scenario, we prefer to use the linear regression, okay, the simple linear regression, right? I will tell you how we can use the simple linear regression, so on, right? So this is the first scenario. Now, if we talk about the multi-level linear regression, so what are the scenarios or what are the condition in which we need to apply the multi-linear regression? Okay, whenever you have input, whenever you have the input column, okay, more than two, right? Right now we are having only one. You are having equal to or more than two input column. Just like suppose we have CGPA, right? And just suppose we have IQ. And at last there will be one output column also. Maybe it is package, right? So in these scenario, whenever you have two, three, any kind of input column, okay, at that scenario we will use our multi-level linear regression. Okay. Now it's time for to understand what is polynomial linear regression. So for the polynomial linear regression, the input column will be it will be greater than equal to 2 itself. The same, okay, just like we have in our linear regression. Okay. Now the scenario is that, so what is the difference between your multi-level linear regression and your polynomial linear regression? Right. The main difference is that the main difference is that here and in this case, right, your data will be linear. Your data will be linear in nature. I will tell you what is the linear in nature, right? Your data will be linear in nature. That means whatever line, whatever the prediction line we will make, it will be always linear, right? But in case of polynomial linear regression, your data will be non-linear. So this is the major difference, right? This is the major difference between these three things. These two will be linear. It will consist of only two columns. The one will be the input column, other will be the output column, right? Whenever we talk about the multi-level linear regression, okay, it will have the more than two columns in your input, right? Like CGPA and the IQ, and these two will be linear in nature. It will have the linear nature, okay. But if we talk about this polynomial, okay, so maybe let's suppose a kind of example we can take room number, right? Room size, and it could be price. Just taking a random example, okay, quick. Even I also not sure whether they will be non-linear or not. Just taking a quick example, just to understand, okay, that these column will be non-linear in nature. Okay, when we will deal with polynomial, so I will tell you what kind of data we need to take, right? So this is the basically the division of your linear regression into three parts. Okay, so our job will be we will take the data set, right, and we will perform the linear regression with the help of our the very famous library, SQL library. Okay, we will import our algorithm from there, we will import our model from there, we will fit our model, we'll train, right, and after that we will try to predict the output. Okay, so this is the scenario. So let's start with the simple linear regression. Okay, let's understand what is the mathematical concept, or a little bit, not that much of depth. Okay, because in linear regression it is too much depth, so we can basically, without taking the help of SQL, and also now we can make our own class also. Okay, by making our own class we can basically perform the same thing rather than depending upon the SQL library. Okay, so I don't think that thing is to be needed. Okay, so we will just use the SQL library and we will try to predict, right? Now, starting with this thing, what is simple linear regression? So, simple linear regression is nothing but a statistics model used to do model to develop the relationship between the two variables we have. Okay, just like we have taken our IQ and package, right? The two variable. Okay, the first one is your independent variable, your predictor, your x, and your dependent variable. That means your response, that is y. So this will be treated as x, and this will be treated as y. Okay. So what will be our goal? Our goal will be to find a linear relationship between our x and y, right? And this is the kind of expression that we can see. And I hope everyone knows this expression y is equal to mx plus c, the very very famous expression in mathematics, right? The equation of a line. Yes, y is equal to mx plus c. M is your slope, right? And x and y are your data point, right? Any point you have, and c is the coefficient, right? So now understand how your linear regression actually work. Okay, on what parameter basically your linear regression dependent on, right? So whenever you have this kind of data set, x y, let's suppose this is x, this is y. Again there will be x, then will be y, so on. So there will be 1 2 so on x in number, right? Here also y1 dot y1 number, right? So, what is our main job? Our main job will be to basically find the value of m and c in such a way that this kind of equation, when we will put upon this data, this will be the unknown data. Let's suppose now, whenever we will try to basically give any kind of unknown data to just predict what package he or she will hold, right? That means we are trying to give this as an input data, right? So we need to find out the value of m and c, right? Yours slope and your coefficient value, okay, which is the best suited value, so that we can get the exact answer uy, right? So this is the mathematical interpretation, or you can see, or you can say the intuition behind the linear regression, right? So let me repeat this thing. So let's suppose whenever we will try to make a linear line, okay, this linear line is nothing but your equation of the line y is equal to mx plus c, okay? Y is equal to mx plus c. We have x data in our data set, we have y data in our data set, okay? We will train our model, we will train our model in such a way that we will try to find out the value of m and c. Why we want to find out the value of m and c? Because whenever a person is using our model, our linear regression model, simple linear regression model, he will give x as the input data and will try to predict the value of y, right? X as the input data, this we need to find by training our model these two parameters, right? And this will be your output data, okay? So this is the mathematical intuition that you can understand that what is simple linear regression, okay? So the same thing has been written over here, right? Along with that, one more thing is that this is called your error term, right? So I will explain you what is this error term, maybe after some time, right? So we have some kind of matrix in machine learning, which are basically, you can say, some standard parameters are there, which will basically define the accuracy of your model, okay? So yes, so any doubt, means anyone till here, that what is y is equal to mx plus c? Okay, why we are using this equation, right? So I hope making sense. Yes. Okay. Yeah. So before going to train our own model using simple linear regression, yes, we need to understand some kind of matrix. Okay, so these are some key matrix for that regression evaluation, that means to just judge your model, right? You can say judge if you want to judge your model, so you have some kind of matrix. Okay, many of you know also that r square is there, right? So r square is a kind of matrix that it tells that independent variable explain the variability in the terms of your dependent variable, right? And its value range from 0 to 1. Okay, the higher the value means the better is the performance of your model. Okay, so this is the one thing. After that, we have one more parameter. This is called mean square error, or we can say in short MSE, right? So your MSE stand for 1 upon n. 1 upon n means your total number of data set you have in your data, right? The number of rows you can say, okay? And yi minus yi cap. So yi cap is nothing but predicted value, your predicted value for every x and y, right? You will have now some y, if this and this, so what is the predicted value, right? Yi cap. Okay, so the average square difference between your actual and your predicted value. Okay, next we have one more parameter. Just see this now. Maybe in the next class I will tell you by doing the code also, right? How you can use these parameters in basically evaluation of your regression model, right? Just look at this, because I have used these kinds of parameters in the code, so you won't get confused what are these parameters, so on and so on. So just giving you the brief introduction, right? Next we have the mean absolute error. So mean absolute error is nothing but it is also kind of formula based, 1 upon n, right? Summation mod of yi minus yi cap, right? So the average absolute between your actual and the predicted value, right? It was the square. This is the absolute value. That means it will be positive in nature, right? Whenever we talk about any kind of absolute value, that means it will have the mod. That means it is a positive value, right? After that, we have RMSE, the root mean square error. It is nothing but the root of your MSE value. Whatever you will get from here, you will just do the under root of this, right? So you will get your RMSE value. Okay. Next we have the adjusted R square. So adjusted R square for the number of predictors in the model to prevent the overfitting in our data set, right? So this is also a kind of mathematical formula based, right? Okay, your R square value, right? So total, what we will see total 5 parameters. Okay, whenever we will train our model, whenever after training our model, whenever we will fit our model, okay, our model is this. Okay, now we will check the accuracy of the model, and for that purpose we will basically utilize these 5 parameters, right? And each parameters is basically showing a kind of you can say uh, a kind of uh, output, right? A kind of output that will basically differ from one form to other form. Okay, they will understand that what I'm trying to say, right? Meanwhile, after some time, okay. So these are your some key parametrics for regression evaluation, right? So yes, now, discussing little bit more some kind of advantages and disadvantages. After that, we will move to training of our model using some data set we have, right? So it is easy to implement and interpret also, because the kind of simple linear regression model, right? Useful for understanding and predicting the linear relationship whenever we have a kind of linear relationship in our data set, right? In polynomial, we don't have any kind of linear relationship. It will be always non-linear, right? In these two, we will get a linear relationship between our data sets, right? So this is the main thing. Okay, what are the disadvantages that we know? Okay, so this thing we should assume, okay, previously, that x and y are linear in nature, right? So if they are non-linear, okay, so we have to deal with according to that situation. Okay, so this is a kind of, and the second is that it is sensitive to the outliers. Okay, if any kind of outliers is present in the data, Okay, so maybe it will affect your result, it will affect your model making process and all those things, right? And cannot handle the multiple predictor, right? It means that to suppose you have the multiple input in your data set, right? X1 or X2 and after Y. Okay, so for that purpose we will use the multilinear multiple linear regression or the multi-level linear regression, you can say, right? So this is the simple kind of introduction between your linear regression. Okay, and this concept is important. So if you want to remember, just remember this mathematical concept. Okay, that we have the x data, we have the y, this is your output column, this is your input column. We are trying to just predict the value of m and c, which will basically help us, okay, to predict the value of y whenever we will give any unknown value of x, right? So this is the base formula, right? So this is something very very important, right? Anyone is having any doubt, means still here in the theoretical concept of the linear regression, that what is linear regression and how it works actually?
Linear, in case of non-linear, it will be square cube kind of thing. Na?
Yeah, definitely. Yes.
Actually, I had forgotten those.
Yeah.
Okay. And for linear, it will always be a straight line, and if it is curve or something like that, it is non-linear.
Yeah, exactly. So there will be kind of thing that if there is a curve now, we can basically make this thing, right? One linear, and just consider this part. So it will make a kind of curve also. So we will see that how we can do this thing, right?
Okay.
Okay. So okay, I hope no one is having any doubt in this theoretical part, right? Just remember this thing now, this thing and this part only. Okay, this is something very very important, right? And okay, now moving to that coding part, right? So we will have a data set, right? And in this data set we are having again the two column. The one is your input column, right? That I already told you. The second one is your output column, right? Output column is package, the input column is your CGPA, right? And the two column, so we will use the linear regression for this purpose, the simple, right? So what we will try to do, just you can just mention the step also, right? The first we will load some kind of library, right? We will split our data set, right, in X train and Y train, right? If you want to look at the data, you can look your X train data, you can look your Y train data, right? If you want to see. After that, what we will do, we will basically import our simple linear regression model, right? Once we are imported, what we will do, we will basically try to fit. That means we will try to train, right, over this data set. Okay, once we are done, what we will do, we will basically do the matrix evaluation, right? We will do the matrix evaluation. Once we are done with the matrix evaluation, just predict the output, okay, on your y test data. So these were the some, you can say, 6 to 7 steps will be there, right? Moreover, in every machine learning algorithm, you will get only these 6 and 7 steps, right? So these are your some kind of step, and mostly you will be, if you able to write on the code now, then you will be able to understand each and everything in a very very good way, right? So we'll start with this thing, okay? So I have uploaded this placement.csv data set. Okay, the same thing, that CGP and your package. Okay, so reading the data set placement.csv, right? And if you want to see, you can see the data set, right? And how many column we have? Let's see. So we have two column and 200 rows in our data set, right? So the more number of data, the more is the good result, you can say, right? And this is the major reason why the machine learning models are still working in today's world, because the machine learning models are very very good in working with the small amount of data also, right, as compared to your deep learning model. So this is the a major reason, if you want to just understand. So that is why if there are 200 rows now, so machine learning model can work on this. If you want to train your deep learning model, it won't work, it won't get give you that good accuracy, right? So kind of thing you can know that difference between your deep learning and your machine learning, right? Now what we will do, we will try to basically
Can you explain again the last line difference between why it will not give?
okay, so the major difference between your DL and ML is that ML basically deal with less amount of data, right?
Right.
And it basically deal with the large amount of data. So this is the major reason why there is a still existence of machine learning in today's world.
Okay.
Okay, whenever a new kind of experiment starts, right? Always there is a less amount of data.
But
Whenever someone,
like when you try, you don't have enough data, you are using ML for finding which algo to use. But when slowly, gradually your data gets increased, it becomes very large. So that algo
yeah,
will be changed.
yeah, exactly, exactly. So people used to do jump from the machine learning to the deep learning. So that's a very common thing.
Algorithms will be different, right? In deep learning as well.
Yeah, algorithm will be different.
Okay, okay, got it.
Okay. Okay. So now what we will do, we will basically try to plot the scatter plot between your CGPA and the package value. We will just actually want to see how your data distributed in scatter plot, right? So what we will do, we will basically do the scatter plotting between your CGPA and X level. We are taking your CGPA, and the Y level we are taking your package. Okay. Once we will run this thing, so you will see that this is your data set, right? And now how you can make the intuition, or you can understand this data set. Suppose if the person is having the CGPA just 4.5, so he will get the package of around 1.6 LPA, right? If the person is having the CGPA greater than 9, right, he will get the package of around something less than 4.5, right? So for each and every point, it is making a kind of intuition, right? Just like this, every point you will take, it will make a kind of intuition, and you can just understand by this way, right? You can take any point, right? This point or this point, any point. Now what we will our main job, why we are basically making this kind of a scatter plot, right? So what our main job is, we have to make a linear line, we have to make a linear line, okay? And this linear line will basically tell you the value of slope and your coefficient, okay? Your value of your slope and the coefficient. Why? Because suppose a unknown person came, or a new student came, okay, in a class, or he just asked my model, okay, so my cgpa that is the value of x is 8.73, right? Now tell me what will be my package. So to tell you package means your y value, you need the value of this mx plus c. You know this value, you have to find out this value, you have to find out this value from this, by finding out this line. Okay, so this line will basically help you to find out these two values, right? A line, okay, a line is nothing but your y is equal to mx plus c. So what we will do, we will try to find out the different value. This value will have different MNC value. This value will have different MNC value. This value will have different MNC value. This also, this also. So uh, in a broad way, you can say we will find the average value of M and the average value of C, right? In a broad sense, you can say, which will satisfy all the point whatever present in this, right? We will find out the value of M and C. That value, these two values will basically try to satisfy all the points, right, present in your data set. So this is the important concept that what we are trying to do, right, in a mathematical way. Okay, so I hope clear to everyone, right? So our next job will be to use these points, to use these data set and just find out a line. Okay. From this line, what we will do, we will find out the mx plus c, your m and c value. Okay. Once we get these value, just store these value in some variable, maybe m1. M1 will store your M value, the C1 will store your C value. And whenever the new person come, he just give you the X value and want to know what will be my package. Just use these two variable, put in this equation and find out the value of Y. That is why this is called your a complete stats concept, right? Or you can say the mathematical concept. Okay, because it completely based upon the formula. It is also kind of formula. We are just trying to find out the MNC value by figuring out. Okay, and this thing, right? So I hope making sense. Okay. Now what we will do, we will just again divide this data set. This will be our train. This will be our input. This will be our output data set, right? So in the X and Y, so you can see your Y is this, right? So if I want to just go for X also, so you can see, okay. So this is your X again 200, okay, one column in your data set. After that, what we will do, the same thing that we are doing from the uh, many of the classes, okay. We will try to import the sklearn library. From that, we will use dot model selection. From model selection, we will basically import our train test display. Okay, it is also kind of algorithm. Okay, and what this algorithm do? This algorithm basically divide your data set into X train, X test, Y train, and Y test. Okay, and test size is this point 2, random state is 2. I already told you what is random state. Okay, by default people used to do go for 0 to 45, anything, any kind of value you can basically give to this random state, right? So random state is nothing but suppose you are taking x amount of data for training. Just suppose x amount of data for training, okay, but you have some x plus 4 data, x plus 4, not x plus 4, just suppose you have 4x amount of data, okay, and you are just taking x amount of data for the training. So at that scenario your random state will be 0, because you don't want to change your data though you have the 4x amount of data. Let's suppose you have written random state is equal to 2. That means you will use the x amount of data and again you will use some other part of this data, again x amount of data for training part, right? That means you are using two new amount of data, you can say, for your training purpose, right? So that is why we have written the random state is equal to 2, right? In the same way, basically whenever you want to change your data set for training purpose again and again, so this is the kind of random state value, right? So this is the one way. Okay, after that what we will do, from the sklearn again we will use importable linear model, right? And this is our linear regression model. Okay, we'll make our object a kind of object in which we will basically store this function, or you can say the method. Okay, so this will be the object. We will try to fit okay, upon your X train and your Y train, the same way that we are doing, and we will do the same kind of things in the upcoming classes also, right? So, okay, once we are done this thing, once we are able to fit this thing, okay, now what we will do, we will basically draw this line. We will basically draw this line over your scatter plot diagram, okay, and this line will basically give you the value of your slope and your coefficient, right? So once we will try to draw, so you can see this is the line, okay. So this line is nothing but, in a broad way, you can just see this is line is nothing but the line representing the average value of slope and the line representing the average value of your coefficient for all points, right? Because we will use these 2 points for predicting our model result, or for predicting our result, right? Okay, so this is the one thing. Now I will show you. Um, where- okay, right, once we are done with this LR, okay, this is your linear regression model, okay. What we will do, we will again use some matrix that I already told you after before some time, right? The mean absolute error, you can just directly import, right, from matrix class. The mean squared error, your R2 error, right? So these are some kind of matrix evaluation parameters that you can use, okay. So what we will do, we will use our y predict data set. This is our y predict data set, okay. We'll test the values. So these are your testing values on your y predict data set that we have already taken at the time when we are doing that splitting part, right? In your y test and y train, x test and x train, right? So this is the result, or you can see the output of from that scenario point of view, right? After that, what we will do, just apply this thing. See, mean absolute error will basically have two parameters. The one your y test, the other is your y predict, right? Just write this function. This is a function mean absolute error, y test, y predict. Okay. In the same way, y square error, y test, and y predict. Okay. Mean square error, y test, and y predict. Okay, maybe right now you have just understand, okay, these are some kind of evaluation parameters, but in actual, maybe in actual, what these are actually doing, what these are actually doing, what these are actually doing, or what kind of meaning they are conveying to me or the end user, okay. Maybe you are not aware, so no need to worry, okay. We'll discuss this thing in the next class. So I will discuss, I will basically dedicate the whole class for these things only, right? Because they are very, very important. Because in each and every, whenever you will train a kind of certain particular model, you will find out these values, right? Right? So it is important to basically go through these concepts also, right? Now we are able to do this thing, right? So again we have R2 square. Yes, R2 square is also kind of matrix evaluation, y test and y predict, okay. So you can basically predict the print your R2 square also, right? Okay, so this is your R2 square value, okay. Now what we will do, now what we will do, I guess till now, okay, so I've included the new feature over here. So mm, okay, just a minute. Okay, so what we will do, if you want to check for the accuracy of this thing, if you want to go for the accuracy, right? So for checking the accuracy, what we can do, we can basically use the R2 square value, right? So the accuracy of this model will be 77%, right? Till now, just see till this point, right? So after finding your matrix evaluation, right? So what we have found it out, we have found it out our accuracy value. It's coming around 77.49 something and something, right? So whatever data set we have used for the X text, right? This data set, 40 minus 1, 40 minus 1 minus 1, 1 for your output column that we have neglected, right? So this is this. Okay. Now the thing is that uh, how we can basically see, okay, what will be the value of this slope, what will be the value of this line coefficient, and so on, right? So to see this value, what we will do, we will basically use a kind of parameter, the coefficient one, right, and your slope one. So these two parameters will basically tell you the result. Okay, so this will be the coefficient of your linear line, whatever you have made. Okay, and this will be the slope of this linear line, whatever you have made. Okay, so whenever we will try to predict the output, okay, this will be the output of this will be the output of this x data, right? So at that scenario, we have to use these two parameters, right? Okay, so this is all about your simple linear regression. Okay, so I hope any doubt to anyone means still here. I will show you that slope also and the coefficient also how you can get. Okay, so I have written the code in that multilinear regression, that thing. Okay, so I will show you there the same thing, and there also they will find out your M and C value, and again that these 2 points will be used in prediction of your new data set, right? Okay, so right, I hope no doubt to anyone, right? Okay, so now what we will do, uh, just moving to this scenario, right? I hope you will understand this multilinear regression also in a very very good way, right? So basically multilinear regression is very very similar to your linear regression. Why? Because it is basically help you to basically make a linear line, right, for the prediction purpose. But the one major difference is that here you will have two or the more independent variable. That means the value of x1 x2 so on and so on, right? And there will be only one dependent variable, that means your output. Okay, so this is the equation of the line. Y is equal to mx1 plus c. Okay, so mx1 mx2, right, plus so on plus c. So this is the equation of the line. Okay, and you can also add one more coefficient, that is your error. Okay, so this will be the equation of the line when we are dealing with the multiple linear regression or the multilinear regression, you can say, right? So okay, the
Abhi,
same
in
thing.
our previous, sorry to interrupt, in your previous
Yeah.
example, linear equation, what was the
Mhm.
value of M and C?
Okay, what was the value of M and C?
Like you,
That,
yeah, you told the M and C will be kind of average value, kind of.
yeah, yeah. So that value I will tell you just a 2 minutes, right?
Okay, okay.
Yeah, I will tell you the value of M and C because these are the two important value here also that will basically
Fine,
decide
fine.
your result. Okay, so the thing is that if we talk about the some of the advantages of your multilinear regression, can handle the multiple predictors simultaneously, that is your x2 x2 and x3 value, right? And help us understanding the relationship between the variable, right? Many variable if you have in your data set, x1 x2 and x3 and so on, right? And it help us to predict the outcome more effectively, right, as compared to your linear regression. Simple linear regression. So this is the scenario, right? Now what I will try to show you, I will try to show you how you can basically deal with the multilinear regression technique. right? And I will also let you know, okay, that to find out the coefficient you can use this thing, and to find out the slope you can use this a kind of formula, right? So okay, let me first show you a scale on slope and coefficient. So okay, so just okay, so see, so uh, just like we had did now till here, that this the linear regression we had fitted, right? After that, what we can do, if you want to go for the coefficient, you can write this thing, okay? So it will give you the coefficient value for all, and it will give you value, basically the slope value for all, whatever your x data, whatever the y data you have, right? The complete. So what we need to do, we need to just sum up all the coefficient, and will divide it by the number of rows you have in your data set. So that will give you the average slope. In the same way, we can do for the average coefficient also. So in this way, you will get the overall slope and the overall coefficient of your complete data set. Okay, and we'll use these two values in the prediction purpose, just like here. We have used these two, right? So this is the scenario. Okay, I will tell you in this multilinear regression how we can use this thing. Okay, so okay. So just a minute. Okay, so what we did in this scenario, in the multilinear regression, so we have basically taken, we have not imported any kind of data. Okay, we had make our own data using this make regression function, right? So there is a function in sklearn dot data set. If I can show you, I can show you sklearn data set, right? So see, these are your famous data set present in your SQL library. Okay, diabetes, digits, wine, breast cancer. So these are some kind of famous data set. So these kind of data set are present in such a way for that practicing purpose only, right? And these are much more famous. So in the same way, what we can do, we can basically imported our own data, that is make regression data from this data set library, right? So once we are done with this thing, okay, so we are trying to make this data. So you will see our data will be basically stored in this your x and your y. Okay, if you want to see the data, I can show you the data set also, right? So this is your data set. Okay, the one and the two feature, this is your target value, means your x1, your x2, and this is your y value, right? That we had made. Okay, so total number of sample we have taken 100, the number of feature we have taken 2, right? And these are two feature that is important in predicting your result, that we have mentioned over here too, the target value, and the noise we have given a kind of you can say the random value in your data set, that are 100, that are 50, right? The kind of noise that we used to give. Okay, after that, what we did, we have basically made our data set and stored in our df, your data frame. Okay, so if you don't have any
In
kind of data,
CSV
suppose you,
frame, we have not
sorry.
used that. We have not used that read CSV file open.
Okay,
So
because we are not importing data from anywhere, we are making the data, right?
we are making the data in the sense I didn't get. Can you please?
Okay,
Till now
I
we are
thought it will
importing
be
data,
okay.
and based on
So
that we are applying X Y trend.
exactly,
So
exactly. So see, in machine learning also give you one more feature, okay, that you can make your data set also. So maybe I don't think this was the right. I need to get the data from somewhere. Okay, just consider one thing that in machine learning you can make your data set also, just like we do now. You just take some random data, right? You
Right.
just take some random data and store in some CSV file, right?
Right.
Okay, in the same way you can generate some random data using make regression function also that we have in machine learning, right? Just like these now, these kind of data, load iris, low diabetes, digits, linear rut, wine, breast cancer. So these are some of the data, right, that have been made in machine learning and have been stored under this class data set. Okay. In the same way, if you don't want to load these kinds of data, you can just make us random data
Okay.
at your own, just making a random data. Just consider this thing, right?
O-
This is not a good practice, because why I am basically making this random data. The reason being is that I have to just show you, okay, we are having two parameters and one is your target parameter, just nothing, right?
We have just three columns, right? In this.
Yeah, just
Target
three column.
record
You
and
can you
particular
can take,
columns.
definitely you can use if you have some other data set, na, that CGP and IQ and your placement, you can
Right.
just import that data set also, right?
Okay.
So okay, so okay, once we are done with this thing, so this is the random data that we have generated. Okay, this these data. Okay, once we are done with this thing, see, this is the one, two, three, right? One dimension, two, and the three dimension that we have already taught. Okay, so what we will do, we will try to just plot the diagram, right? Your scatter plot diagram for 3D data set, right? So maybe this, for the first time you will see a kind of 3D structure of any data set, right? So let me show you. So this is the 3D structure of a data set. Okay, you can visualize this data set in a very good way in a 3D space, right? So see, we have just give me, see, we have the target value. Maybe you can take the x-axis, right? Y-axis and your z-axis, right? By keeping this point, not this one, maybe this one. Okay, x, y, and z. Okay, so that will, see, x, y, and z, right? Your 3D data set. This is the way now we basically draw the 3D points, right? And for the 2D we do this thing, right? This is your 2D and this is your 3D, right? So see, everything you can see over this data set. Whenever you will click on any particular, let's suppose we are clicking on this. Okay, you can see the feature one is having this value, feature two is having this value, and target is having this kind of value, right? If you want to check for this, if you want to go for this any kind of number or any kind of data set, you can just see how it has been plotted in 3D space, right? A kind of visualization. Okay, so right, so this is a kind of visualization in the 3D space. Okay, just like we did in the 2D, so it is in the 3D only. Okay, now the thing is that the same thing again we will do. We will basically divide this data set into your two part, your x and the y. We will split our data set, right? So again using sklearn, right? So what we are doing, we are basically dividing our data set. We'll import the linear regression model, right? And right now we are taking, see, everything is same, nothing has changed. Now the thing has been changed is you that you have the two input data set, right? You have the two input data set and one output data set. The model name is also same, nothing has been changed. Okay, The reason being that all are the part of your linear regression, your simple polynomial and your uh, linear regression, right? So this is the thing. Okay. So once you are done with this thing, just load your model, you load your algorithm, you train and try to predict. Okay. And this thing we have already seen that the matrix evaluation, the mean square error, your MSC value, your R2 square, and so on, right? So these are your MSC values and all those things. Okay. Okay. Uh, See, these are your coefficient value. If you want to check for the coefficient of each point, right? For each point, let's suppose there will be one point. There will be one point whose feature value is something this, whose feature two value is something this, right? And okay, and this will be something y, right? Your output value, and this will be something. Let's suppose it is 26.3 and it is the 3.86, okay, and this is 4.27, let's suppose. Okay, our job will be for this, find out the value of m and c. So you will find out the value is this, and for the intercept value, let's suppose it is coming around this. Okay, so in the same way we will basically find out the slope value and the intercept value for each point, whatever the point we have in our data set. We'll do the average of all the coefficient and all the intercept point, right? And after that we will basically use these in predicting the result whenever we will get the new data set, right? The new value of feature 1 and the feature 2 we will use to predict the again the y value. Okay. The same thing that we were doing in simple linear regression. So I can show you there also in simple linear regression. Just copy this thing, right? So okay, right. So the coefficient is coming around 0.57. This right, and again for the intercept also you can see. So right,
Abhinay, coefficient is m value and intercept is c, right?
sorry,
Coefficient is m and intercept is c.
yeah, coefficient is m. Yeah. I guess m it is. Let me check. Just a minute. Just a minute. This is your coefficient value, your c value, right? And this is your slope, intercept. This is your c
Intercept,
value.
intercept is m. Okay.
Yeah, intercept is mi. Intercept is mi, guess, right? Even my math is also not that good. Okay. So once you get these 2 points, right? Just use your y is equal to mx plus c. Put these value over here, put this value over here. If you have the unknown data set, put the value over here, you will get the y value, right? So the complete mathematical based concept you can see, right? Just like we solve the equation, we find out some unknown variable. So these were your some unknown variable. We just found out these unknown variable. We have some this value, just put and solve the simple, right? So this is how your simple linear regression works, right? In the same way, your multilinear regression also. So if you have see here, your coefficient is two. Why? Because we have the two data set, the two column we have. Each column is basically uh, giving you one one coefficient for one column, one coefficient for other column, right? And there will be only one intercept, one coefficient value. See what happened now. Let's suppose this is the one line, right? And maybe this will be the other line. Okay. So if you will calculate the slope, this value or this value, the slope will differ from one line to other. So these are two other line, and the coefficient will be same, right, for both the line. If you have one more feature, then you will get one more data point, right? And we will utilize in this y is equal to mx1 uh, m1x1 plus m2x2 plus m3x3 plus c. If you have three features, you can see in formula also. Now I told you this thing: m1x1, m2x2, these this value, right? x1, x2, x3, and this will be a single value, your intercept, and this will be your slope, right? Complete mathematical concept. I hope making sense, right?
Yeah, actually, program-wise, there is nothing. There is
Very,
no
very similar. Yeah.
single and multiple, but
Even
depends on number
concept
of
is,
features which we are using. Coefficient will return how if there are two features, it will return two values.
exactly
Otherwise, programming-wise, everything is same.
same. Everything is same. Yeah. I hope making sense, right?
Yes.
Only the important thing is that just remember this formula, right? And just remember this thing. Why? Because we need to find out these value only, right? And we need to find out this value. So these are your unknown variable. If you are able to find out this variable, these value with the help of a line, okay, then you can put in this expression and you can find out your y value. The same we have done with this also, right?
Abhinay, but practically we are not doing anything. We are just finding out coefficient and intercept. The application of program is itself giving. So remembering the
Practically,
equation and finding out what was the value and all, it doesn't help us kind of thing. Application is
uh,
doing everything, right? We are able to find out what are the values m1, x1, m1, m2, x2 and all by using this intercept and coefficient.
yeah.
And in that case, the 20th wala thing, 1 minus R2, 40 minus 1, how this will work in case of multilinear?
Which one?
Um, some formula was there, 1 minus 40 thing.
uh,
Yeah, yeah,
okay, this one.
yeah.
Oh, this formula is dependent on your R2 square
Okay,
value.
yes.
So this will I will tell you maybe next week, right? When I
Sure.
will explain you na all things, MAE, MSc, and other thing. So at that instant I will tell you, okay. So after finding out this error, so this will be your accuracy of the model.
Okay.
That's why see we have subtracted from one taken as 100%, and this will be your error. So whatever you will get error, let's suppose we are getting 23 over here. 100 minus 23 will give you this kind of
Right.
accuracy, right? Making sense?
Yes. Actually, different algo are giving different error, right? Mean square, mean, one you are squaring that.
Yeah. We will see which parameter we have to take,
Okay.
right? Among MSC, MAE, R2 square, right?
Right.
Which will be the most relevant one,
Okay, okay.
right? We can write MSC also here, right? We'll do the
So
same thing.
whichever is giving you best output, is it like we have to use that or it depends
Huh.
on the data set?
But whichever is giving the best output,
Okay.
right? So I hope clear now. So just uh, telling you one more thing that what I have done over here. So what I have done, basically we have the linear data set over here, right? Your we are having the two column in this CGP in the package. What I did, you can basically convert this data into your this multilinear also, right? You can basically attach one more column, so that will be automatically converted into, say, so just included one random feature over here, right? Random feature. Now you have the two input column and one output column, right? And we'll again jump to this thing. So if you want to make, you can make. Suppose somebody has given you the simple linear regression and one input, one output column, and they told you, okay, apply the multilinear regression. So what you will do? Just make one random feature column, okay? This one, and they take these two and just go for multilinear regression. A kind of thing that I want to tell you. You don't want to go, no issue with this thing because we have already seen this thing, right? Okay. So I hope yeah, clear to everyone, right? And this was your 3D dimension, right? In 3D, how you can basically visualize your data set. Okay.
In the
So shall we,
any, we can specify any number of rows or any number of columns.
where?
The, we are reporting make regression, right? Which will
Uh-huh.
which will give you
Yeah,
basic.
you can give any number of. Suppose you want to make for 100 random numbers, you can go for 100. There is no issue with that.
But the field value will always be number or can be string as well. So
No, they are mostly not mostly. I can say they are number itself.
okay,
Yeah. Because if we talk about some textual data, so that will be something else, right?
right,
Maybe that will not make any kind of sense. So the generating some kind of random data, which will be textual in nature, will not make any kind of sense also, right?
right,
So that will increase our work. So
right.
that is why maybe they are just giving you this value.
And there will be no outliers kind of thing. If they are
Yeah, definitely. Hmm. Okay.
thank you.
So shall we conclude? Yeah. Any doubt to anyone? Right. So in the next class, we will see just those matrix evaluation parameter, and we'll check for the polynomial regression. Okay. Because whatever the simple method we have now, algo, we will finish quickly, right? And we'll focus on the larger one, your logistic regression, your random forest, XGBoost, and all other things, right? That will take a little bit of time, okay? Because we need to start deep learning also. Yes,
Yeah, but what I would like to request, we can make some kind of project as I already discussed. We
we
can
can make.
we can make a sample project kind of thing.
Yeah,
From
yeah, we will make. We will make. I have two to three projects. So one is the I have the data set of the Swiggy. So we will try to predict the sales, right? We will try to predict the sales also. And the second, I did not remember the second one. Second is also, I guess, it is associated with the YouTube data set, right? So we will take the complete data set. We'll make two to three projects. Definitely we will do. Okay. Before
And
jumping to
Abhinay,
the,
yeah,
yeah.
Abhinay, if you can, like, or show the like deployment ways also, like multiple deployment ways for this as well.
Okay. Yeah, I will show you. I think I. Okay, I have. Okay, so once you train the model, na, we basically download the model in our PKL file or H5, right? If you know this thing, right? So once we are done with this thing, now we can basically import this model to AWS also in Microsoft also anything. Okay, and once you are done with this thing, you can basically use your model and make a complete pipeline. I will show you this thing also, that how we can basically make the complete pipeline from training our data, making our model, deploying our model into server, right? Whenever the new data will come, that is your online learning, right? So passing that new data to your model, okay, and helping to predict the result, okay. So this thing we can also do. right? We'll do for our one project, okay?
Right.
And we will use a kind of UI.
Clarity.
Yeah,
End to end will from scratch to deployment, it will give us more clarity actually.
definitely, definitely.
Practically how it
So,
works in industry.
okay, okay. No
You're saying
issues.
something, sorry I interrupted.
Yeah, yeah. So I wish saying that we will use a kind of UI also, that normal UI, right? So you can use the Streamlit also for this purpose, or maybe we can go for some HTML, CSS also, the small kind of thing. Okay, right?
Okay.
So shall we conclude?
Yeah, sure.
Okay,
Yeah.
thank you.
Thank
Thank
you.
you.